All right, good afternoon, everybody. Everybody find this place okay? Anybody not make it here? I'm just kidding. So welcome to Simplifying Blockchain Development with Azure Blockchain Service. My name is Mark Krasinovich. I'm CTO of Azure. Just want to get a view for how many people went to the intro talk I gave a couple hours ago. How many people were there? How many people were not there? Uh-oh. Actually, so I hope all of you that weren't there already have a basic understanding of blockchain. Is that true? Okay, good, because this assumes a basic understanding of blockchain, and really this session is exactly what the title describes, which is to show you the technologies and tools and services that we've got in Azure that will help you get up and running with a blockchain project quickly and efficiently and solve business problems that are suited for blockchain. So let's talk about the agenda for the presentation. I'm going to start by introducing Azure Blockchain Service, talk a little bit about what it is, show you a little demo of it in action. Then I'm going to talk about something that we've released called Azure Blockchain Development Kit for Ethereum, and I'll be showing you a demo of that as well. Then a focus on really enabling blockchain for all kinds of developers, whether you're somebody that codes or somebody that doesn't code, where you're somebody that just looks at analytics for a business solution and that is built on top of blockchain, what we've got there for you. Talk a few minutes about blockchain DevOps, the process and our guidance for developing a blockchain application and how you do that using the same kind of CI/CD pipelines that you do for regular code development, but with considerations for a consortium-based blockchain. And then finally, I'll talk about a really exciting announcement that we've got this week, which is the Confidential Consortium Framework. So let's go ahead and get started. Now, I want to preface this by talking about how we at Microsoft and Azure got to where we are today to share these things with you. And it's been a long journey. You might have been following us since back in 2015 when we first started to get involved with our customers and found that many of them were looking at blockchain, and it was very much the era of what's the question, blockchain is the answer. So everybody wanted to play with it, and one of the big challenges with it was setting up a blockchain framework to even play around with it and understand what it was. So we, at that time, started to introduce templates, Azure Resource Manager templates in the marketplace that would let you go to the portal or command line and deploy a blockchain node very quickly. And over time, we started to add multiple ledgers. So we've got probably a dozen different ledgers, several dozen different templates up there. So whether it's Quorum or Ethereum or Corda or Hyperledger Fabric, you can deploy single node networks, multi-node networks. You can even deploy networks that span Azure geos with nodes in different regions, something that you would want to do if actually it was a production network. Well, that was great for getting started, but our customers wanted more. They wanted actually a way to understand what kind of applications made sense for blockchain, and this is where we started deep engagements with enterprises to look at the scenarios that looked like might be applicable to blockchain. Once you get past the FUD of blockchain's the answer for everything and really look at what its key value propositions are, we found a whole number of different scenarios, and I covered them in my intro talk when I showed across all different verticals, from retail to finance to healthcare to manufacturing, all sorts of scenarios where blockchain could help groups of organizations better efficiently transact with one another and execute workflows together. So that's where we came up with some of the guidance for where blockchain is applicable and where it's not. And then where we are today and where we started about a year ago was getting towards the point where, okay, now we've got a basic understanding of what really the scenarios are like and what businesses want to do with blockchain. So let's start creating higher level solutions that let them go from idea to deployment or proof of concept or dev test to explore things very quickly. And then this latest step, which we got announced today at Build, is actually to go to production with higher level services that let you focus on the blockchain application, where we take care of everything else, and where it really meets business needs, which is blockchain is not something in isolation. Just like a database is at the heart of many applications, there's lots of application infrastructure around that database that interacts with other business systems, that has UX on it, that interacts with other databases potentially. And so that's something where we wanted to make sure that our blockchain solutions could help enterprises accomplish those things. And when you take a look at all of the things you got to do to stand up an application on top of a blockchain, it goes from launching and managing the network. Like I said, it's creating those Ethereum nodes. It's adding members to the Ethereum network. It's creating other nodes, joining them to the network, having them communicate with each other, managing the keys, and then care and feeding of that low-level infrastructure. As far as the application goes, that's where you get into smart contracts. Designing smart contracts, versioning smart contracts, testing smart contracts, debugging smart contracts, deploying smart contracts, permissioning smart contracts. All of those things are part of the smart contract development process. And then finally, like I said, taking that application built on smart contracts, extending it to work with other business systems. So if you take a look and break that down a little bit further, it's all of these different tasks. And many of our enterprise customers were just overwhelmed. We saw projects that would go from, hey, here's a cool idea with blockchain that I want to go explore and maybe even take to production, take 6 months or a year to get through all of these different steps. So focusing on exactly how to get customers up and running really quickly, obviously the big announcement this week is Azure Blockchain Service, a fully managed ledger service. Our initial target is Quorum ledger, but we've got other ones in the works. And the amazing thing is with this is we worked with customers and private previews on this and getting them started on this to validate this was really meeting their needs. We actually saw customers go from that morning, they'd already done some proof of concept work, they had an idea for the application, they'd done desk deployments on top of networks they'd built themselves. They took those smart contracts, they deployed them on Azure Blockchain Service and went to production with it that very same day. So if you've got the idea and you know what you're going to do, you've got an idea with the smart contracts and you know how to integrate the application with the rest of the systems, you can literally go into production with our SLAs, with nodes, blockchain networks that span multiple nodes, where even the nodes aren't necessarily even part of Azure. There could be nodes that are on premises, they could be nodes running on other clouds, because that's what consortiums are about, lots of different organizations, each one's coming from a different place. Of course, we'd love it if they were all on Azure, and they can be on all Azure, but that's not the sole design point for Azure Blockchain Service. And Azure Blockchain Service starts with this foundation, which is we stand up the underlying services underneath. This is kind of a SaaS blockchain service in the sense that you stand it up, all of the underlying infrastructure from the databases that power these dashboards, to the management of the nodes, to the upgrading of the nodes. All of that happens without you having to worry about it. So you get insights into what's going on. Like I said, you can join existing consortiums. In the case of there's an existing Quorum network out there, you can use Azure Blockchain Service to join it or create a new network right from the UX. And then also, you can do governance right from inside this portal. So one of the big challenges, too, that enterprises have had with their consortiums is how do you do governance? How do you invite members to the consortium? How do you remove members consortium? How do you, when you've got consortia, in all cases, it's not like one entity controls who's member. So in many cases, it's a voting process. And so even blockchain service is designed for those scenarios where you can vote and then understand it, invite new members to the consortium and then track their membership. So let me show you a quick demo of what that UX looks like. So let me switch over here to the demo machine. And I'm here in the Azure portal, which in the wizard for creating an Azure Blockchain Service instance. And you can see that we're asked to create a blockchain member. And that's really what this is focused on, is creating the member because you're representing that member, and you get to decide how that member, whether it's standing up a new consortium or joining an existing one. I'm going to go ahead and deploy it in West US. So you can choose which region you want to deploy it in. And then here you can see this drop-down, which lets you pick from an existing consortium, if you want to join an existing one, or create a new one. And we can create a new one, of course, if we're going from scratch. And then you can see the protocol here. It's Quorum, and it's grayed out. That's because that's what we support today. Like I said, we're going to be introducing support for other ledger types coming in the near future. And then you specify the member information. Now, I've already got a few consortiums deployed in Azure Blockchain Service. Here on the left side, we'll see Consortium 1, and then on the right side, Consortium 2. These are all represented, each member as Azure Resource Manager objects, so they can be RBAC controlled. You can manage the keys in Azure and Azure Key Vault with the identities in Azure Active Directory. So from your perspective, managing your membership of your nodes or nodes, you've got full control of enterprise capabilities for RBAC and identity. I'm going to click on one of the members so you can see here some of the dashboards. You can see blocks and transactions processed by your nodes. If you click on one of the members here, and because I created this and I've created multiple members for each of these consortium, I've got access to all of the members. So I'm just showing you the view of one particular one. You can see the blocks and transactions that member's nodes has seen, the pending transactions and the handled requests. And then from that membership view, you can also go back and look at the other members and see their status. And this is where governance would take place. So that's a quick look at Azure Blockchain Service. Now, let's talk a little bit more about what we've got coming this week, or announced this week, to support the things that you want to do once you have that basic foundation up and running. And of course, those things, like I mentioned, are connecting to your existing business systems, scaling out to production, and then building and managing those smart contracts. And Microsoft being a developer-oriented company, we understand all of the things that you need to do to actually get a smart contract, an enterprise-grade smart contract, not something that you're just testing and playing around with, but all the things you need to do to get that smart contract up and ready for production, and as part of an integrated blockchain service. These are the steps that we see all our customers have to go through. Linting, compilation, deciding which type of network to go onto, and then developing microservices because you want to interact with that smart contract using other applications. So an application that might execute a transaction on a smart contract, you need to write the front-end code that takes inputs from your business systems and then calls into the blockchain, the smart contract methods, and executes them on the blockchain. Database integration, like I mentioned, publishing to Power BI so you can look at dashboards of what's going on in the application, what's going on in the, so you get the idea. Lots of different steps. And we're focused on simplifying a bunch of these, some of those with Azure Blockchain Service, some of those with another service called Azure Blockchain Workbench I'll talk about in a little bit. But what we've also focused on, like I said, is around the development experience. As a developer, the one that's responsible for creating the smart contracts that represent the business logic or workflows that you're actually going to implement on blockchain network, we've done some work to get you up and running really quickly. And if you're familiar, how many people have developed a smart contract and deployed it to a blockchain? So quite a few of you. And you know the tooling is a little bit rough today. What we've found is that lots of our customers struggle with the tooling. Truffle's a great development environment. You saw me show it earlier today for Ethereum development. But one of the things that lots of the customers we've talked to, whether they're working on Ethereum or Quorum or other ledgers, is, hey, I want to just do this the way I do my normal code development. I want to use my favorite IDE, and what's your favorite IDE? Visual Studio Code, right? So, of course. I want to use Visual Studio Code, and I want to develop my smart contracts in that, and I want to do builds from Visual Studio Code, and I want to do deployments from Visual Studio Code. I want to debug my smart contracts in Visual Studio Code. In fact, last October at DevCon, blockchain conference, Mark McCurry, who's up here in the front, one of a program manager for our blockchain team, was at the conference, and a couple of people came up to him and they said, hey, we were just over talking to Vitalik Buterin. How many people know who Vitalik is? I hope everybody, if you're here at a blockchain talk. But Vitalik, the creator of Ethereum, he said that he would really, really love if he could do Ethereum smart contract development inside of Visual Studio Code. So much that if you do that integration, he'll come to a Microsoft conference and wear an Azure t-shirt. So, Vitalik, here he is. So come on up, Vitalik. So we're going to prove to you that that you're wearing that shirt for a reason. By the way, this is Biddle Azure shirt. So little, I know you know what that means, but we'll come back to that later. Don't spoil it. Mm-hmm. But let's go show the integrations. So let me switch over here. I'm on the dev machine. And I'm in Visual Studio Code. And the first thing I want to do is, hey, I want to create a smart contract, but I'd like the scaffolding for it to be set up for me just to getting started so I don't have to type in all the basics myself. So I'm going to do Control-Shift-P to pull up the command palette, and I'm going to say, hey, I want a new Solidity project. So that's part of the Ethereum dev tools here for Visual Studio Code. I want to create a basic project. Here's the folder that I'm going to create that project in. And now Visual Studio Code is off generating a whole bunch of files that represent a basic smart contract project, including the deployment scripts, as well as the Solidity file that has a very kind of hello world. In fact, it's called hello world. We'll see that pop up here in a second to get started. So just a few seconds more, and we'll have our, I promise you, we'll have this here. And what is going on here? There was an error? All right, let me try it again, actually.
Yeah, we'll watch carefully.
Okay. This has worked, oh. What is going on? Yeah, really? Ah. Okay, you're right. We did have to reboot it. Should I report this? No. Good. So you can see this is pretty hot bits, but let me try one more time. Oh, it looks like it was still doing something.
Fatal error, zone allocation, committing semis, space.
Okay. One more try.
You sure the thing isn't just out of memory or something?
Actually, that could be the case. I have to use this lame tool, but...
Visuals? No, it's
No.
moderate. Okay.
Okay, well... Actually, last time it just...
I mean, I saw the thing yesterday. You can actually do stuff. You can actually do stuff.
Yeah, okay, so this is... we probably need to clean the whole thing, and I don't know... Do you know what the file... All right, let's try it again. File. I don't know. I think we want to create a new one, but open folder, yeah. This has worked like 10 times so far, so I don't know what is...
Well, no, okay, hold on. Let's suppose I'm a new user and I download Visual Studio for the first time, so I don't have a folder yet. So what do I do?
If for this, let me try it again.
Okay, so new Solidity project.
And it's, okay, so we're not having good, the demo gods are frowning on us. I think Vitalik's having some kind of weird effect up here. It senses Vitalik's presence and it's nervous. What you would be able to see is, this is in the theme of the HoloLens failure yesterday morning, I guess. But what you would be able to see, and I'm not just going to walk off stage, I'll describe what you would see. So you would have seen a hello world contract. It would have had a few properties. It would have had a few methods. And what I would have been able to do after that generated is deploy it. Deploy it to Truffle locally, deploy it to Ropsten, deploy it to Azure Blockchain Service, that consortium deployment that I had.
Can I deploy it to a public network?
Absolutely you can. Of course you can. Otherwise, we wouldn't have invited you here.
Okay.
Public Ethereum network is one of the networks you can deploy to. So I would have shown you deploying it to a bunch of those networks. And then there's another step that I would show you in a second, but I'll get to it and describe what that is. But Vitalik, I'm sorry that this failed in front of everybody with you up here, but I've already told people that you actually saw this in action, and so that's why you're here wearing that T-shirt. So thanks for coming.
Yeah, no, thank you. That's good.
All right, so let's switch back and talk a little bit more about what we're going to show you. So besides building, like I said, deploying, testing, so there's a test guidance, like we've mentioned, and then there's integration. And one of the things that, where's the video? There's a slide that looks like it wasn't updated with the video in it. Oh, here it is. So here's a video that will show you. This is actually in action. So this isn't in the initial development release, but you'll see right here is live debugging of a smart contract inside of Visual Studio Code with a breakpoint. And you can see with stepping, working. This is the first step. The next step will be showing you variables in the smart contract too, properties, so you'll be able to actually do like real world development like you would with any other kind of program, whether it's a C# program or whatever, right sitting inside of here with Solidity contracts. We're constantly shipping code, and so this initial release of the dev kit is just an initial release. There's releases that you're going to see over the next few weeks and months that will flesh this out. In fact, we think that we'll be able to release a debugging experience like this in about a month or so. So stay tuned. It's going to get even better than the crashes that you saw in the failed demo here.
This is definitely looking really useful.
Yeah.
Yeah.
So what you envisioned?
I guess so.
Okay. Okay, good. Close enough. All right. Well, thanks, Vitalik. I'll bring you back up on stage at the end.
Okay.
Okay, let's, now one of the challenges, though, with our enterprise customers is that not everybody's a sophisticated developer like you in the audience probably are, where you can pick up Solidity and figure out how to write a smart contract and deploy it. They're people that are more business-oriented developers, professional developers, ones that understand databases and integration systems. And we wanted to make it possible for all of these different types of roles to integrate and leverage a smart contract-based solution. So we've got a bunch of technologies already inside of Azure that are really aimed at those kinds of developers. And we've decided to connect those, enable them for blockchains, whether it's a blockchain that's running on Azure Blockchain Service or your own blockchain that might be running on a raw set of Ethereum nodes that you created and set up yourself and managing yourself. So available today, one of the components that we've got for these kinds of developers is the Logic Apps Connector. And what the Logic Apps Connector lets you do is trigger off of smart contract events and also integrate with other systems and execute smart contract transactions automatically. So one of the key parts of this integration of an application with business system is, hey, something showed up. There's a service ticket that showed up. Now I want to execute something on a smart contract. Or I just initiated a shipment of a new batch of pharmaceuticals. Well, I want to execute a smart contract transaction. And what I can do is execute that by registering that on some other business system that I've got that's tracking what I've done in those other business systems that then kicks off a transaction on the smart contract because I've got a Logic app that is sitting there watching for example, tickets showing up in ServiceNow and then kicking off a Logic app transaction through the Ethereum Logic App Connector. We also have support for creating microservices that interact with smart contracts. So if a developer wants to, hey, I want to call a smart contract myself from my C# application, how do I do that? Well, we've got Microservice Creator that I would show you if the demo was working because it would have been the next step, is to take that smart contract that I had, that hello world, go to the command palette and say, create a microservice. And what we can do is generate a microservice for logic apps, or for Flow, or for Azure Functions. And so at that point, you've got, for example, an Azure Functions app that consists of a bunch of functions, a function for each property, for reading each property in the smart contract, and a function for each method in the smart contract. So at that point, it's as simple as deploying that Azure function. It's already wired up to talk to that smart contract address. And now you can start invoking that Azure function to go and integrate with the smart contract, with the blockchain. So that's built into Visual Studio Code. We also have some updates for the Logic App Connector. So this Ethereum connector that I just talked about, we actually released that about a couple months ago, I think. What we've done is, at Build this week, is deployed it in all regions around the world, including our GovCloud. How many people here do work with government customers in Azure GovCloud? So a few of you. So it's available there. We know that's important for government customers. It also supports private transactions. Private transactions is something that I'll show you a demonstration of in a little bit. So let me show you one of the really cool scenarios. This is actually a legitimate scenario from one of our pharmaceutical customers. The business problem they have there is they do a bunch of drug trials. Now, drug trials, of course, you try the drugs on a whole bunch of different patients, and you register a whole bunch of information about the patients and the effects and various checkpoints about the drug trial as their patients are being monitored. And then when you want FDA approval, you have to produce this evidence to them. Now, one of the challenges that they have themselves is they've got, of course, potentially insiders, people that are working at the company that maybe are a little too aggressive about getting their pharmaceuticals approved. They basically don't want to be faced with any question that they followed procedures correctly in doing the drug trial, that there's been no tampering with the evidence. So when they produce the evidence to the FDA, ideally, the evidence is accepted by the FDA. It's cryptographically assured that the drug trial evidence that they're sharing with them actually was entered on a blockchain at the appropriate dates and times and hasn't been tampered with. So that's the real legitimate scenario. And the blockchain, of course, with its hashing and immutability and smart contracts and proof of when they went into the and the blockchain, the sharing of the the blockchain with the FDA lets the FDA see exactly what's going on with the drug trial. So really cool scenario, and I've got a demonstration of that here to show you using Azure Blockchain Service and the Logic App Connector. So let's switch over to this Logic App. Now this Logic App, actually, the Logic App is right here. So this is an OCR Logic App, and if I go and edit it to look at what the steps are, this is where you see the Ethereum connector in action. So let's follow the steps here. So what this is doing is, first step is the Logic Apps connector for SharePoint. And this step in the workflow is when a new file is dropped in this SharePoint folder, go, and the next step, do an OCR on it using the Cognitive Services OCR API, using that connector. What's going to come back is the text that's been recognized from that document. At that point, we've got a custom steps using Azure Functions to hash the various aspects of that file, the OCR data that came back from the file. One is to hash the original file, so we know that the OCR came from that file. Another one is to hash the OCR text, binding it to the file, and then hashing the metadata that represents that file. All of that's been hashed, and at that point, we're ready to go call our smart contract. And here's the Ethereum Smart Contract Connector. And if we look at this, you can see that what's going into that smart contract are all those various hashes. Now let's go take a look at what one of these documents looks like and kick off one of these workflows. So we've just created a sample set of documents here that would look like potentially a drug trial set of documents. Here's patient A. We've got patient B. Patient C, patient D, patient E. And what I'm going to do is just go back to our SharePoint folder that the Logic App is monitoring here, tracked pictures, and upload one of the files. So this file is uploading, and what that's going to do is kick off that logic app. If we go back to the logic app designer, and we go to look at its executions, what's going to show up here in a few minutes, or a minute or two. Let me do a refresh here. And that's it right there. It's already finished. So that logic apps workflow has already finished seeing that document, calling the smart contract function. And so let's go take a look at that. And here's the smart contract call right there, which passes in the various address right here. And the network is acting really slow. But you can see that it starts with 6C. Just remember this first part because we're going to go and verify that we're going to see, when we look at the blockchain, that we see that smart contract being executed. And we can see actually the functions. So let's go take a look at that. We've got a blockchain explorer right here. Let me do a refresh. And this is pointing at our Azure Blockchain Service smart contract. And there you can see that's the same hash for that smart contract address. If we click that open, then you can see this is the function that we just executed 2 minutes ago. We go to additional details. Oh, well, let's click on that transaction. We go to initial details, and we say view. And then you can see the inputs. And actually, if you decoded this, you'd be able to see that the hash of the document is one of the parameters is sitting right there. So if we went back and looked at those outputs from the Logic Apps connector, we'd see that that's it. And so that is that end-to-end workflow of drop the document, execute OCR, drop it in the blockchain. And at this point, that is there for the FDA or anybody else to go verify. What they can do is, hey, FDA, this is the drug trial information. There's the documents. FDA gets the documents. They hash them. They do OCR on them. And then they can verify that all those hashes match what's here in the ledger and that hasn't been tampered with since the time that patient information was recorded. So really cool, and just a few minutes to set up that Logic Apps workflow. If you haven't used Logic Apps, it's kind of a WYSIWYG workflow with enterprise integration. Over 200 different connectors, and we've just started to create these connectors for blockchain. The first one's Ethereum. Of course, more is coming. Okay. Now, Logic Apps is a pretty straightforward tool. It doesn't require all that level of sophistication. You don't have to be a power programmer to use Logic Apps. Nevertheless, we do want to reach the citizen-type developer, the ones where Logic Apps is still a little too complicated. They're more business-oriented. They're not coding-oriented. Even Excel expressions might be a little stretch for them. And so let's reach them. And the way that we're reaching them is with Microsoft Flow. If you think of Logic Apps as kind of low-level PaaS solution for workflow, Flow is like a SaaS for workflow. It's something that even citizen developers can get up and started. You don't have to deal with the kind of expressions that you do in Logic Apps. The logic is even more simplified. Now, that means that it's not quite as powerful as Logic Apps because you can do more in the low-level expressions of Logic Apps, but you can still accomplish a lot of really cool scenarios with it. And then Power Apps. How many people have used a Power App before? So a few of you have. Power Apps is one of the, I think, underappreciated assets in the Power portfolio at this point. Power BI, everybody knows. Flow, a lot of people know. But Power Apps, we see tons of customers that go from idea, like I've talked about earlier, like that application we just saw right there, to a Power App that their users can interact with to, for example, upload documents, to look at the status of documents. And with basically no code. It's like a PowerPoint designer is the way you would develop a Power App. And once you develop a Power App with the steps, connectors to data sources in the back end, at that point, you can deploy it either as a web app, or you can deploy it as a rich client-side app, or you can deploy it as a mobile app. And what I'm going to show you right now is another scenario, which is Flow plus Power Apps for a slightly different scenario. This is a refrigerated transport scenario. It's another one that's a real-world customer scenario. The problem here is, as we're shipping goods through a supply chain, we've got something that needs to stay within certain humidity and temperature parameters to actually not be spoiled. So Buehler is a company that we work with, supplies, I think it's 75% of the world's grain comes from Buehler systems. Well, anybody like that wants to track where the stuff came from, make sure that it's within parameters, shipping parameters, so that they know that when it gets to the end grocery store or the end customer, that it's actually in the condition that it's supposed to be and it's not going to cause any problems. So the way that they do this is, as the shipment goes through the supply chain, it's being tracked with IoT sensors that are measuring the temperature and humidity it's exposed to. So it might be a container that has some sensors on it. And when somebody takes it into possession, it's been transferred to them, they go in, register using the smart contract, using the sensors, the state of the shipment, what temperature and humidity it's been exposed to. When they hand it to the next organization in the supply chain or the next person, they also register it. And so you have this handoff where everybody knows the condition of how they handed it off and how they received it. So if something goes bad with it, it's very visible right in the blockchain where it went bad, under whose control the shipment was when it went bad. And then you can go figure out if they're not handling the products properly. You can also know that if there's a whole batch of things, that only that batch that came from that particular shipper is spoiled, and so on. You get the idea. So we've set up an example here of smart contract shipping built on Azure Blockchain Service with integrations with Power Apps and Flow. And let me show you that here. And for that, I've got an app that I'm going to, on my smartphone, that I'm going to show you. So I'm going to connect and wire my phone up so you will be able to see it in real time. And there we go. And here's this this Power app. So this is a Power app we developed. This is connected to Flow, which is connected to Azure Blockchain Service. And the smart contract records the status of the item that we're shipping through this. And you can see there's a bunch of different shippers and sources. For this would be dairy. I'm going to log in as me by tapping that. And now I'm going to create a new shipping contract. So you can see here the form that we created that I've got to fill out. And what I'm going to do is I'm going to say that I want to have dairy industry observe the shipment of this dairy item and press OK. At this point, this is talking to Flow, which is then talking to the Ethereum smart contract, the Ethereum connector for Flow, which is dropping these parameters into the creating a new smart contract and dropping these initial parameters into it on the blockchain, Ethereum blockchain. Now, the next step in the shipping process would be to transfer this to somebody else. So what I'm going to do is transfer, and I'm going to transfer it to Contoso Courier. And so I just, like the Contoso Courier representative is sitting right there taking delivery of this thing. I just scanned his barcode. And now, once I've handed it to them, we can complete the shipment and say it's delivered. So I just press the complete button. Again, all of these backed by Flow talking to Ethereum smart contract. In fact, you can see up at the top, just for debugging purposes, we're printing the transaction hashes. So now at this point, I can go back and take a look at the list of shipping contracts, and there you can see the record of that. This also, just to show you what it would look like in the case that we're actually going to create a failed version of the smart contract. So I'm going to press OK here. And you can see the humidity parameter 0 to 80. You can see the temperature 2 to 5. So I'm going to press OK to create a new instance of the smart contract for this secondary shipment. And at this point, I'm going to pretend that it went out of compliance by setting it. And this would actually likely happen with smart sensors on the package that would then be, this would be reading from. I'm going to send that into the smart contract. So this is recording that the shipment's out of parameters. Now I'm going to transfer it again. And we're going to be asked who to transfer it to. Again, and then we're going to complete this. And at the time of completion, when the smart contract's basically closed, it's shipped to its final destination, it's going to be marked as a bad shipment. So 1 second here, and then you can see the transaction hashes. It's completed. And if I go back, now we're going to see the completed shipment. And if I, actually I should have shown as out of parameter. So you get the idea, Flow connecting to the smart contract, registering this, tracking this. And one of the things that I just mentioned that we announced this week with this Flow and Logic Apps connectors is the support for private contracts, where only some subset of parties see the contract information. So I'm actually not going to walk through the step of creating a new one completely for you, but you can see at the bottom of this display, that's where you can specify who can see this smart contract, which other members of the consortium. And so we might not want Northwind Dairy to see it. And that's all going to be honored by the smart contract that's going to be done in a private, as a private contract. So that's a quick look at Flow plus the Logic Apps connector. So if you take a look at the kinds of applications that this is setting up, from ingesting data like we just saw, it could be from an IoT device, transforming the data, attesting the data, and this is where the attestation happens. Blockchain is the source of truth of the history of that item. And then back-end systems, which are, you can see the distributed ledger watcher, which could be a Logic app, or it could be an Azure function that gets kicked off there. You can see power-ups at the top, event grid. And so all of this is supported through today in that way. So I've just shown you the kind of basic first step of integration, but we see customers that are building these kind of very rich applications with lots of different workflows that kick off when a smart contract executes or an event happens on the smart contract. So how many of you have played with Azure Blockchain Workbench before? So Azure Blockchain Workbench, like I said, we released last year. And what this does is let customers stand up and play with the smart contract. It will automatically generate a UX for a smart contract-based application. It will automatically generate a rich client app, a Xamarin app. It will create a REST API. And so then at that point, you can start doing things like what I just showed you with the smart contract. Well, what we found is, and we weren't sure where this was going to go, but our customers told us, hey, this is awesome for dev testing our smart contracts, but when it comes to actually production, after we've figured out what we want to do, we're going to go build custom UIs. And so we realized that Azure Blockchain Workbench really is kind of that dev test sandbox for creating the smart contracts underneath business application that you were creating. But one of the asks that we had from enterprise customers is, hey, I don't want to, I've got this dev test environment basically for smart contracts. I don't want to have to manage it. And what Azure Blockchain Workbench did was stand up a whole bunch of services underneath, and including the ledger itself, but it didn't manage them. So Azure Blockchain Service, of course, is fully managed. We'll upgrade all the ledger nodes ourselves. You don't worry about their health. You don't have to worry about it. It's all being taken care of by us. So now we've migrated Azure Blockchain Workbench to leverage Azure Blockchain Service. So now it becomes really, truly fully managed with full management of the underlying ledgers. And so it's a sandbox that you can play around with and keep for a long time, reusing it to play with different applications. We've also, like I mentioned, released the document Azure DevOps Guidance for Consortiums. You can see this right here, which provides you some guidance learnings that we've collected from enterprise customers about how to develop a smart contract and a CI/CD pipeline for testing and deploying smart contracts. Now, the last thing I'm going to talk about is something called confidential computing, and a contribution we've made with big announcement this week here at Build. Confidential computing, that's a term that we coined here at Azure. We've been working on the concept of confidential computing since about 2014. The idea is you've got what are called enclaves, or trusted execution environments. These are black boxes where the access to that black box is controlled either through software or hardware. In the case of software, we've actually built an enclave technology into Windows Server 2016 called Virtual Secure Mode, VSM, which is a software hypervisor enforced black box. So even if you're a full admin on the server, VSM is protected by Hyper-V with policies that it enforces for what code can get into the VSM enclave and who can access it. And this is where we'll do things like do key guard, where we'll put keys like LSA secrets and cryptographic keys inside that VSM enclave to protect it from any hacker that might get on the box. They simply cannot get access to those keys and take them off. Well, an example of a physical enclave technology is Intel's SGX. SGX started shipping in Intel processors about 6 or 7 years ago. They're shipping in all of Intel client processors, so Skylake processors all have them. And SGX, the processor itself, creates this black box of encrypted memory with cryptographic protection of the integrity of that data that's in the encrypted memory, such that you can have physical access to the machine, have a bus analyzer sitting on the memory bus, and you will not see anything that's going on inside that enclave. So that's an example. ARM Trust Zone is another example of an enclave type technology that's hardware-based. Now, Azure Confidential Computing, this larger program, consists of a bunch of things, including deploying SGX-enabled machines in our data centers, making sure that they're patched appropriately with any fixes to SGX. But this basically gives you a platform to run SGX-based applications. And so depending on your level of risk, VSM enclaves or SGX enclaves on premises in your own data centers in Azure on Azure-based SGX machines, you can take advantage of enclave technology. We've built an SDK for creating enclave-based applications, ones where part of the code runs outside the enclave, the kind of untrusted can be exposed to the outside world, and then the trusted part, the part that you want to be able to process data in a confidential way. Now, as we've been developing Azure Confidential Computing, we realized, hey, there's a cool problem that confidential computing can address with a lot of blockchains, specifically transaction throughput and confidentiality. Now, if you've been watching the evolution of blockchain, confidentiality techniques have come into play, like Ethereum's introduced ZK Starks, other Zcash, Zcash, another example of using ZK Snarks for protecting the confidentiality of smart contracts. You see private state channels, encrypted state channels as examples of ways to get confidentiality into blockchain. But all of them are relatively complicated and have performance limitations. Well, when you say that I trust this piece of code, which is my ledger code, and I trust the enclave technology to protect it, then it doesn't matter whether the transactions are processed on my server or somebody else's server. I know that they can't get and modify the behavior of that transaction processing code. They can't access the data that it's processing. And so whether it's out in their server or my server, it doesn't matter. And with that, we can create a trusted network of nodes that trust each other by establishing, hey, you're running the software that I trust. You've got the consortium policies that my consortium owner, member owner, has agreed to. And now we can start to share transactions where one of us processes the transaction and shares the results with the others. So that is something called Azure Confidential Consortium Framework, or CCF. How many people heard of COCO when we announced COCO about a year and a half ago? So this is COCO. We announced COCO as a framework that builds on top of confidential computing that will integrate with different ledgers and then achieve database level latency and throughput with confidentiality, where you can apply confidentiality rules that are fairly flexible and dynamically updatable. Because you're trusting the enclave code to enforce confidentiality, you can add RBAC rules to that code, such that, hey, if Mark comes and queries for transactions on the ledger, only show Mark the transactions that Mark has participated in. Don't show him anything else. But then I'll say, oh, you know what? I've got an auditor. The auditor wants to see transactions from Mark and some other users. Plumb the RBAC rules with somebody that has authority to say this auditor can see access to my transactions. And now the auditor can come, and for anybody that's enabled them access to their transactions, the enclave code will say, hey, you can see all these things. And at any point in time, I can revoke it, too. I can say now the auditor can't see these things. So these kinds of flexible access control with confidentiality is something that it's very hard to do with those other technologies I mentioned. So I'm going to show you a quick demo. This is available today. So we've been talking about it for a year and a half. We've been hard at work on it. And we, this week, have launched it on GitHub, CCF. And so let me show you a quick demo of CCF in action. And the way that I'm going to show you CCF in action is by highlighting a partnership that we've got with JP Morgan. Now, JP Morgan, how many people have heard of JPMC coin, which they announced about a month and a half ago? This is a coin that they've tied to US dollars that will make it easier for their institutional investors to transact with one another by having these representations of dollars and coming from their accounts on a blockchain. And so this is something that they're still working on. It's not in production yet. They've done a bunch of testing on it. But one of the challenges they had with it, they're built on top of Quorum, of course, because Quorum came from JP Morgan, is the transaction throughputs of the standard consensus algorithms they get. About 800 transactions per second. And really, when it comes to high-scale financial transactions that they want to perform on JPM coin, they want at least 8,000. They also want confidentiality. And so by creating a second layer network underneath Quorum that's based on CCF, they can achieve that. So let me go show you a quick demo of JPM coin on top of CCF in action. So you can see we've got 4 members of this consortium interacting with JPM coin. You can see their balances right here. And what I'm going to do is go and kick off the script that's going to start executing transactions of JPM coin between those different parties. And you can see that we're getting somewhere north of 1,500 transactions per second. This is still being performance tweaked, and we know that we can get above 8,000 transactions per second on top of Quorum. And the reason why we know that, if I go back to the display, by the way, to show you the updates. Oh, you know what? I forgot to say start refreshing. And hopefully this will work with this order. There we go. So you can see the balance is being updated in real time. And this is a Power App, of course, that's connected to the Quorum ledger that the JPM coins are being transacted upon. So that's why JPM was so excited about partnering with us, and why Quorum is the first ledger that we've integrated with Azure Blockchain Service, and why we've integrated CCF with Quorum to support this very scenario. Now, the reason that we're confident we can achieve the kinds of throughputs that JPM wants, let me go back and I'll show you. On top of CCF, we've actually created another application, a ledger, a homegrown ledger. We just wanted to see, hey, you know what? How fast can we drive a multi-node network based off of CCF with the transactions executing across the nodes with full confidentiality? And let's see what the limit is. So this is basically what we call simple banking app, single banking ledger, which is basically just UTXO-based ledger, kind of like Bitcoin, that is transacting tokens across the different parties. And what this simulator is doing is executing transactions. And it just executed a bunch of transactions between 5 different nodes. And this is the throughput that it got. So that's 56,000 transactions per second. So that shows you, and we've actually got optimizations that push this up to 150,000 transactions per second across 15 nodes. We're doing more improvements. So CCF, again, is one of those projects that's, yeah, here's version 1. It's ready for production. We've got customers ready to go for production with it. But we're going to be improving the performance, integrating with other ledgers. So it's integrated with Quorum now. We're going to be integrating with other ledgers. And we're going to be introducing other consensus mechanisms. Right now, it's pure crash fault-tolerant consensus, which is where you get these kinds of performance. But we're also working on practical Byzantine fault tolerance consensus on top of this, which provides you an extra level of assurance. And kind of cool, how many people have heard of PBFT, practical Byzantine fault tolerance, as a consensus algorithm? Well, the cool thing is Miguel Castro, the creator of PBFT, works in Microsoft research on the CCF project. And so we're like, who could do the PBFT work on this? And it's like, Miguel's like, I think I can do it. So he's doing it, this kind of PBFT integration. And so, and by the way, if you're interested in the details of how CCF works in all the gory, and it's not, while I described it in a trivial way, this is on the CCF GitHub page, which is right here. So this is the CCF GitHub page, which describes it. All the code is there for you to take, build, deploy. You can deploy it to obviously your own servers anywhere, or you can use Azure's confidential computing VMs to deploy it using SGX there. And then here's the technical report that describes its contributions to CCF, why it's different, and its protocols, and how it achieves security, safety, and performance. So that is, we're really excited about that. Lots of customers waiting for that. So, and just to give you an idea of the kind of customers that we've worked with, it's been a whole set of customers, like I mentioned, across all different segments, all different verticals. You can see directly customers as well as partners that are creating solutions for customers. Lots of big names that you're familiar with. You saw the Starbucks example yesterday, big key customer or key customer of ours that's partnering on developing blockchain solutions. So what you're seeing is really the result of working with real customers on real go-to-production blockchain, not just here's some code, try it out, it might work for you. This is really being tested for real workloads. So that brings us to the end of the talk. I hope you found this interesting, got caught up on some of the cool announcements that we've got this week. This is just one step on our evolution to really creating a full-fledged blockchain as a service ecosystem on top of Azure, with our goal being openness. I hope that came through too, which is we want to support you regardless of where you run your blockchain. With things like Visual Studio Code and the dev kit for Ethereum, is you can take that and use that wherever you want, not necessarily Azure. So really it's about working with the ecosystem. Now, one last thing here. Oh, the VS Code demo is working now. So, do I want what? Vitalik to come back up? Yeah, Vitalik, just stay where you are. Don't move. Oh, do I probably have to close the project again? Workspace. Where's the closed workspace? Oh, here, let me try this. All right. Okay, well, anyway, I think Vitalik looked at it. So we've got one last thing. So it's really exciting that Vitalik's here, and you saw him wearing this shirt. This is an extra one, and we're going to give it away signed by me and Vitalik to whoever answers this question. What is the BIDL reference? It's not build. It's a blockchain reference. HODL, there we go. You right there, you won. So congratulations, come up and get your signed t-shirt. We'll sign it for you from Vitalik. Now, me and Vitalik are rushing over to Build Live. We're going to be hosted by Mark Mercuri. He's going to ask us questions about the future of Ethereum and about Azure's strategy with blockchain and what we're doing. So if you can't get in, it's going to be streamed live. So hope you tune into that and see where Ethereum is going from Vitalik. So thank you very much. Have a great build.